as promised, we go back to the main topic, which are acids and bases. Okay? First thing, we go to the definition. First, what is an acid? Anybody? And then what is a base also? Okay? That is the main point. So in our chemistry before in high school or in our grade school level or elementary level, there is a litmus paper as our one of our sources of our identification when to determine and when to tell if it is an acid. Okay, so for example, if the blue litmus paper changed to red, this is an acid. Blue litmus paper changed to red. Okay, like that. And in the acid with the red litmus paper, okay, change to blue. Okay? Right? Now, during memorization, so that it will accumulate in your brain cells, you have to take not only this one technique. So, you will memorize the red litmus paper, change to blue. So, the first letter B, base. So, that's it. And the other one will hold through. So, that's the one technique. So, that you can memorize that every time as you go second year college, first year college, second year college, and even up to 50 years old, 60 years old, you can still remember the definition of litmus paper when it comes to acidity and basicity, right? Blanc with a litmus paper, red turns to blue. Tang! Immediately base because blue letter B is the first letter. Okay, so the other one, okay, when the blue litmus paper change or turns to red, that is an acid. So that's gonna be the technique how to memorize. Okay, like that. And then another definition also, this comes to the ionization. When you speak about ionization, you will introduce a solution. What will happen to this compounds, elements that when a solution is being added, then it will yield to something. Okay, acid will yield H plus ions in solution. Okay, H plus ions, meaning guys, ions, I-O-S. Okay, so it is expected to be ionized. Could either be weakly ionized and strongly ionized as long as it is ionized, the H plus. Okay, something like plus is the charge. Okay, in the solution. Okay, ganon for acid. Like that. But if we will try to intensify more the definition, we will remember the theory of Arrhenius. Arrhenius theory. You get the point, mga palangga? Charot. Okay? Napaon ko, guys.
The Bluetooth device is ready to pair.
If we try to enhance a little bit our definition, we have to follow Arrhenius theory. Okay, Arrhenius meaning to say it will yield hydronium ions in solution. Meaning to say H3O positive. Something like that. Okay? So for example, if you add one water and another water, let's say a volume of water and another volume of water, it will yield hydronium ion. Like that. The ion could either be a positive or negative, but in this case, hydronium has a positive ion. So since ion involves, meaning to say ionic band. Something like that. You get the point? Okay, that's very clear. Now going back to the base, in terms of Arrhenius theory also, if you introduce it in the solution, okay, it will yield a hydroxide, okay, OH, -1, okay? Or in short, in organic chemistry, this is known as hydroxyl group. But in organic chemistry, we will just call that as hydroxide. Get the point? It's not hydroxyl. It's in the organic chemistry that we need to put chuchu, like the alkyl group, ganon. Phenol group, like that, hydroxyl group, what else? There's a lot of LLL chuba chuchu, but in organic chemistry, you don't have to do that. Okay? Only hydroxide group. But it means the same thing. OH negative. Okay? I'm talking only to the applicability of the term. Okay? But it's totally the same, huh? So it's gonna be like that. So OH negative. So this is in solution. Okay? So at least we have now two definitions na good siya. Hindi kayo na. Okay, now we go back to acid. So what is the best example for this? We go to the basic, guys. Okay, like that. Very easy to detect, right? We have, say for example, sodium ion. Okay, sodium ion. Or shall we say sodium plus chlorine? Okay, sodium plus chlorine. Na plus Cl. Okay, like that. So Na. So meaning to say, this is in its free state. Meaning to say, you will never put a charge first unless it will be introduced into a chaos solution that will be charged now. This is the first concept. Okay? If that is a standalone element, you don't have to put charge yet. Meaning to say, it's neutral. Okay? Something like that, like this, if in A pa siya. Okay? And then if added to chlorine, okay, mo na siya ang chlorine. Now, if you try to combine that one already, so this in A will become in A positive. Okay? Plus, this will become chlorine negative. This is now in aqueous solution. Okay? Aqueous solution. So this in this case that we could see either the sodium is ionized completely or weakly, or the chlorine is ionized completely or weakly in an aqueous solution. But if you will never introduce that yet in a solution or any water solution or any solvent, you cannot put charge at the top of sodium and chlorine in its original state because it's still neutral. The point. Okay, if it is charged already, it is in the solution already, like this. Okay, so this is sodium positive plus chloride negative, ganun siya. Okay, take note mga palangga. O diba? So chlorine is electronegative. Okay, ganon. Electronegative. Okay. Sodium is electropositive. Okay? Electropositive. Something like that. You get the point? Now, the electropositive sodium don't need more electrons by himself. Okay? That's why he need to give that to chlorine. Okay? This sodium will give its electrons to chlorine. Okay? So now, the electronegativity of chlorine will increase. You get the point? Will increase. So chlorine will become more electronegative. Something like that. So now, if you try to insert the topic of levels, dot structures, then we will base the outermost shell electrons of chlorine here. Okay, something like that. So sodium have one cut. One cut represents one proton of sodium. Okay, but in this case, guys, be careful because if they have only one, and that is also the electron. This is also the magic sometimes of chemistry because this proton can act as an electron if it's only one, especially if it is a positive. Imagine this is an electropositive and then it will lose the electrons, right? But this is not having too much electrons, this sodium. See? As you can see here. Okay? Sodium. O, diba? Sodium. So, positive 1. Asa man ang electron i-ara? Get the point? So, the positive 1 proton will be automatically also as an electron in the case where it has only a positive 1 charge, something like that, okay? So, and in other cases, we have to analyze pa siya. It depends on the situation. As long as we have the idea, something like this. Okay, guys? Okay, so, 1. Chlorine plus chlorine. 1, 2, 3, 4, 5, 6. So chlorine is here. So we have 7. 1, 2, 3, 4, 5, 6, 7. Okay. This dot will be shared to chlorine. Okay, tadadat. Ganon. That's why it will become Na positive. Okay, ganon. Now, since chlorine is not sharing back his electron, so he will be more electronegative. Then the electron will go back to himself, will be directed to himself only. So that is what we call as electronegativity. If the electrons will not move away from him, instead it will move towards to him. So that is electronegativity process, the more the element will become electronegative. Okay, that's the point. So, dili siya mo hatag back, dili siya mo share. So, it will now become 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 6, 7, 8. It will now become 8. Okay, 8 electrons. Okay, now since that is having 7 electrons and there's an excess of 1 electron, so the excess 1 electron will become now a negative 1 in the charge of chlorine. You get the point? That's why we have Cl negative 1 and Na positive. And if we put that in a piece of paper, we don't have to put that anymore. That's only for the purpose of illustration. Why? Chlorine have negative when you introduce sodium and chlorine into the aqueous solution. Something like that. Since this process involves positive charge ion and negative charge ion, then it is automatic undergoing an ionic bonding. I-O-N. Ionic bonding, you get the point. So ionic bonding, therefore, tantamount to ionic compound. Okay? Now, notice it. Okay? Notice, we have sodium metal and we have chlorine as non-metal. So, metal plus non-metal. So, this is the applicability of an ionic compound when you add metal and non-metal exclusively, and that's the time you can say a compound is an ionic compound. Now, if there is no non-metal, it will never be an ionic compound. That is a covalent compound or a molecular compound. Something like that. But the point that's very clear, right? Any questions so far for this discussion? Okay, now, if we have like this, it's very easy to detect, guys. So we are applying here now the Arrhenius theory of breaking up sodium and chlorine into its individual charge, positive and negative. And we're also using the Lewis dot structure, or the how to determine acidity and basicity by applying the Lewis concept and principle discovered by Mr. Lewis. Okay? We know Mr. Lewis, we know also Mr. Arrhenius. Okay? So we can say specifically now, through my interpretation and discussion and illustration of this, bonding and sharing of electrons. Actually, this is not sharing of electrons, because when we say sharing, it should be giving back to one another. That is only transferring of electrons. And this is highly technical, a little bit. Though it's just the same, but it's not really too much the same. You can point, gosh, mga palangga. A little bit. When you transfer only one party will transfer. Not necessarily the party will also transfer back to you. Okay? But when you share, both of you will share. I will transfer to you, will also transfer to me. But in case of ionic compound, okay, one is only transferring the electrons. Okay, so we can say that OFWs are ionic compound because we are only transferring money to our family, but our family will never transfer money back to us. Okay, if we try to compare this in chemistry, we are ionic compound. Okay? Back then, if our relationship is, if I will transfer money to my family and my family transfer me back at a single transaction, that is molecular band or molecular compound. Okay, so that is an analogy if you try to put into social discussion. Social meaning involves human being. Okay, social or community analogy community involves people. Okay, like that in relation to how to discuss properly. Something like that. You get the point? That's very clear. Now going back to this example only, hindi na tayo lalayo. We go to the broasted. Well, it's not roasted chicken, but broasted. Okay, wow, very delicious roasted chicken, right? It's very crispy, something like that. Oh, we will assume also that this roasted lorry is delicious as roasted chicken. Okay, going back to the discussion. My gosh, I hate drugs. Kakaloka. Okay, ganon. Going back to NaCl. Okay? Like this. Sodium, okay, plus chlorine. Okay. You know, guys, I don't put subscript of chlorine to the atomic because we are not making a chemical reaction here. Okay, we're just purely combining something like that. You get the point? So this is a special understanding of the purpose of discussion. I'm not saying we need to produce a chemical reaction because we are not dealing with mixture. Okay, we are dealing with pure substance pa talaga siya. Okay? You get the point in chemistry study. Okay, like that. Now, we use bronzed lauric acid. Ganon. What's the time this week? See, I'm purely talking. So, goodbye everybody. I'm coming back for my third segment of this live discussion in this interactive virtual platform of communication and discussion. Welcome back to my mighty channel later on. I have to stop this for a while because I'm more than in the required minutes na talaga siya and I'm not comfortable to extend yet. Okay, if you like this video, we go back as promised later on. Okay, you can like, you can comment, you can share. And you can subscribe to my channel if you want. Also, click the notification bell for some news updates of I Am a Singer, Eternal Voice, all about for now, Shine's Vlog. Okay, bye-bye. That is everybody for academic, purpose only. Thank you so much.